Hello everyone, welcome to the video on systems of equations using elimination method. So in the last video we talked about solving systems of equations using substitution method. Today we're just going to do the same thing except we're using a different method called the elimination method. The prior knowledge is quite similar. You need to know how to simplify expressions by collecting like terms. And we also need to know how to solve linear equations. The learning objective is that you can solve a system of two linear equations using the elimination method by adding or subtracting the equations. Let's start from the first example question. Solve the system x plus y equals 10 and x minus y equals 8. First thing, I'm going to write down the equations in a very orderly fashion. What I mean by the orderly fashion is that the variables and the equal sign and the numbers are all lined up nicely. So you can see that the x's and the y's and the equal signs and the numbers are all lined up perfectly. Another thing that I noticed is that the coefficient of x and the coefficient of x on the first and second equations are exactly the same. And that's what we want to make. The coefficient of y, on the other hand, is positive 1 in the first equation and negative 1 in the second equation. And that's not okay. Well, we only have to match one of the variables, so that's good. At this point, what I'm going to do is I'm going to subtract two equations. So I'm just going to do the subtraction here. That's why it's called elimination. We do x minus x. And what's that? X minus x is 0. What about y? I have positive y minus negative y. Minus negative y is the same thing as plus positive y. So that's y plus y. So in other words, that's plus 2y. And I do the same thing for the right-hand side. I'll do 10 minus 8, which is 2. So therefore, I have 2y equals 2. And I can do divided by 2 on both sides to get y equals 1. At this point, I have solved one of the variables. Now I need to go back and solve the other variable. I can use either of the equations. I'm just going to use the first one. So I have the equation x plus y equals 10, but I do know that x plus y can be replaced with 1. I'm going to use a substitute. I'm going to substitute the y value into the equation using the brackets here. But I can do minus 1 on both sides. So that's x equals 10 minus 1, which is 9. So my final answer would be x equals 9 and y equals 1. Let me annotate the process here. The first thing is write the system neatly and aligned. Afterwards, I subtract it after making sure that one of the variables have matching coefficients. I subtract. I subtracted two equations and I have one variable. So here, just solve the equation and then final step is to find the other variable. So first thing, you align the equation nicely. And then you make sure that the coefficients are matching. And then we subtract, we solve one equation, and then we solve the other variable. And we have solved the systems of equations. Let's try another question. Solve the system 2x minus 3y equals 4 and x plus y equals 7. The same thing, I'm going to write the equations down in a neatly way. But then I encounter a problem immediately. Unlike the previous question, none of the variables have the matching coefficients. The x has 2 and 1. Y has negative 3 and positive 1. So what should I do at this point? Well, what I can do is I can manipulate one of the equations so that one of the variables are going to have a matching coefficient. In my opinion, I think if you multiply the second equation by 2 on both left-hand side and the right-hand side, I'm going to have the matching coefficient for the variable x. So let's do that. So I rewrite the first equation as it is, but then the second equation I can write it as 2 times x is 2x, 2 times y is 2y, 2 times 7 is 14. And now, the two equations have the matching variables, matching coefficient for the variable x. So now I think I can do the subtraction, the elimination. 2x minus 2x is 0. Negative 3y minus 2y is negative 5y. And 4 minus 14, you can use calculator for this kind of thing, it's negative 10. So I have negative 5y equals negative 10. And I can divide both sides by negative 5. And once again, you can use your calculator. You get y is equal to positive 2. Let's solve for the other variable as well. I can use either of the two equations here, but I think using the second one will just be easier for my life. So let's replace y with 2. Make sure you use a bracket here. So do minus 2 on both sides. My x is equal to 5. So therefore, my final answer is x equals 5 and y equals 2. Or if you want to write it as an ordered pair, you can do that too. 5 comma 2 is also a good answer. Let me annotate the process and explain the ideas here. First thing I did was I multiplied the second equation by 2 to have matching coefficients. And by the way, in this case, I multiplied by 2 on both 2 because I wanted to match the coefficient of x. If you want, you can also multiply by negative 3 to match the y coefficient. And then eliminate by subtracting. So here you see the meaning of the word eliminate. It has two meanings here. One, we're eliminating because we're doing the subtraction of equations. Two, we're eliminating a variable from the equation. Notice how at this point we had two variables, but after you eliminate, you only have one variable to solve. And we know how to solve one variable equation. And then solve for the other variable. So here's some vocabulary in the formula that we need to know about. First, the systems of equations, as we said in the last video, it means that we have two equations and two variables. And in this level, we're only going to deal with the linear equations. The elimination method is, as we discussed in this video, it's a way to solve a system by adding or subtracting the equations to eliminate one of the variables. The coefficient is a number multiplied to the variable. So if you have 3y, the coefficient is 3. It's important when we do elimination method that the coefficients are matching. And finally, the solution is x equals something, y equals something. It's a pair of that solution, or we can also represent it as an ordered pair in the format of open bracket x comma y close brackets. Thanks for tuning in this video, and I'll see you in the next one.